There we go. Today we're going to talk about JSON and APIs. So this topic and the next topic are basically ways that you can get data from the internet. Two of my favorite topics. I think once you have this, once you're equipped with this knowledge, you can basically have whatever data you want, almost pretty much. So to get started, we have to first talk about what a JSON file is. So JSON is basically a file type. You'll see them end with a .json, and pretty much what it is, it's a giant dictionary. Because these dictionaries are very large, very likely you would be provided with a JSON schema. And if you're using an API that's well documented, they will also have a schema for you. Just because in a giant nested dictionary, it's hard to explore it just through your Python code. So here you can see this is an example from the New York Times API. So New York Times actually has a really good API. I'm actually going to walk through like how I use the New York Times API. They have many different ones for, I think, for news, for movie reviews is one of them. They recently started a COVID-19 API, which you get data on COVID, which is pretty awesome as well. All right, so to get started, you can see here, this is just an example of a JSON schema that was provided for the New York Times API. So here you can see that probably what this is, I think these are news articles. So you can see here you have like the web URL for the article, a snippet of it, lead paragraph, abstract, what it is, headline, and more information on that article. Here you can even see some metadata. So master structure is a dictionary and has a bunch of keys.
Yes, can you explain what an API is?
Oh, yeah, really good question. I'm actually going to talk about APIs in the second section. We're just going to start with like the data type of JSON, and I'll get into API.
Okay.
Yeah, but that's a good question. Sometimes, yeah, that is a hard question to answer, but hopefully that what I'll say later makes sense. But yeah, API basically give you data in a JSON file format. So that's why we're talking about JSON first. All right. So if you're provided with your data in a JSON file, this is how you load it. Some sources of data, I know like Yelp, other than their own API, they actually release their own curated data set of businesses and users and reviews. And all of that information you can actually download in a JSON file. So if you don't feel like curating your own data set from Yelp, you can actually download their open data set. They release a new one every single year. I actually did my capstone project using that data set, and it comes in JSON files. So knowing how to use JSON files and also saving things to JSON files, which is what we're going to talk about at the end of this JSON section, pretty important. So to work with JSON files, there is a JSON package. Very, very useful. All we have here, as you can see here, there is, oh shoot, this JSON file is not here. Let me quickly move that in and give me a sec. Copy this. Oh, so likely the version that you have on GitHub right now doesn't have it, but I'll add it right after this. Let's copy and paste. All right, so over here, you can see I have my New York Times response.json file. If we click into it, it opens up here. Not the cleanest, but you can sort of tell that it's a dictionary with somewhere nested lists. All right, so let's get back to our notebook. To open the file, this is a pretty common format that you might come across when you're working with not just JSON files, but other data type files. I think if you open a text file, it comes in this format. We're going to talk about sometimes CSVs open with this format as well as we're going to talk about in the next phase, pickles, also open in this format. But anyways, what this is doing is you're assigning to a variable an open object. And with this line, you're opening this JSON file, and the R stands for read. And then you're just loading this open file. So let's run this, and I assigned all of the information that was in the JSON load to data. So really quickly, if I was to output data, we have all of this in our common dictionary format. And then just to like quickly see what it is, you can see that the type is a dictionary, and the keys of the first layer is status, copyright, and response. So usually, I think, as I'd mentioned with, I think, one of our topics before, when I'm given like a big chunk of data, I always like to quickly explore it. Yes, we do have this schema here, but sometimes it helps to look into it on your own. So loading specific data, you can probably guess that other than the first couple keys of like status and copyright, what you really want will be in response. So let's take a look really quickly into response. Let's actually look here, data response. You can sort of tell that, all right, it is a single key here that seems to have a nested list. But just to double check, let's take a look at the keys. All right, we have docs and the metadata. From this, all right, let's take a look into docs. And in docs, you can see that this is a list that seems to have all our stuff in here, all of our response data. Oops. And usually when I'm presented with a list, I just like to look at the first thing. So really quickly, the first thing here is a web article about, I guess, someone who spent this much money for some election, I'm guessing. But to go one level deeper, this is the information that we have. We can take a look at it, at its keys, and then basically from here, you would be able to extract the data you want, write a couple functions, turn it into a data frame, which is actually what we're going to talk about here. So just a little bit more exploration before we get into it. We talked about the docs, which here is our list of, I guess, article information. Let's just explore a little more. The type is a list with 9 docs in this response. And let's just get the headlines. So here you can sort of see that, all right, there is a headline key. And then I realize now for each headline key is actually a nested dictionary. And maybe for this purpose, I just want to get the headline itself. And just by inspecting this, the main headline is nested under the main key. So really quickly, let's just print this. These are all our headlines. We're looping through that list of article information. Here I'm printing out the main part. And then I've gotten a couple questions about this. Anything with a \n just prints a new line. So as you can see here, everything is separated by a new line. Without this, everything's clumped together. So sometimes, because a notebook is often what you use to present, just for cleaner printing, you want to put a new line. That's how you do it. Questions so far? This is very similar to what we were talking about with like working with nested dictionaries and nested loops. Just running through your dictionary, trying to find out as much as you can with like these little functions like keys, like exploring the first item of a list. Yeah, questions so far? Awesome. Had a question about breaking out nested dictionaries. Very often, because pandas is what we know and love, and we like to do our data cleaning with pandas, we often want to take what we have in our JSON file or in our dictionary format and turn it into a data frame. So, of course, first we need our pandas. And let's take a look at what happens if I just were to dump that list of article information into our data frame. So what we can see here, for the most part, kind of works. We have our URL, our snippet. The downside is it turns each key in our dictionary to a column. So for example, remember we had like how the headline was a nested dictionary? The entire dictionary would be nested as the value in this cell. And so that's a very common problem we have with when dealing with like JSON or APIs or anything in a large dictionary format is it's unlikely that you'll be able to straight away turn that into a data frame unless there's only one layer in the dictionary. So there are quite a few different ways to break it up. And this just to show, if we take a look at the headline, the first one, it's a dictionary. So quite a few ways to break out nested data. This is the example from from one of the lessons, I believe. And basically what we're doing here is we're going to create a new sub data frame that actually breaks out all the information from these headline cells. So these headline cells, within them, there's like the main kicker, content kicker, all of these. These are going to be new columns in our new data frame that we will then concatenate to this existing data frame. So just to like walk through this, yeah, just to reiterate, there are multiple ways to do this. If you can think of a way with Python to do this in a more efficient way, by all means, or in a way that like makes more sense to you. So cool. The way that this function works, you start by getting a list of the dictionary keys because those will be your new columns. And you can also keep track of the columns we'll make for later. And we'll take a look at what that is later because you're going to append stuff. But first, we're going to loop through our dictionary keys. We're going to loop through the keys of this. We're going to loop through these. So as you can see, we're doing df.headline.ilook0.keys. So literally the keys of this very first dictionary. So, all right, that will be our new column. And the new column names, just in case, you know, there are other columns named main, kicker, content kicker, we want to format each new column name to be headline underscore these. Just in case there's like another column, I'm actually not too sure if there is, but just in case you have conflicting column names, you don't want that to happen. So just so you can keep track of which columns came from unnesting a dictionary, we're doing that. So we're gonna construct these new columns. And then for each new column, we're gonna map the information here. So what we're doing here, from the data frame, for this big data frame, we're just gonna create a new column with the header of the new column. And then we're gonna map. So we're gonna look into the headline and then pick out the specific value from this key. Does that make sense? So what we're doing is we're going into the headline column, which is here. And based on whichever key we're looping through, pull out that value. So as you can see here, we're pulling out the value of that. Cool. And then you'll append it. So really quickly what this looks like. We have our headline main, headline kicker, all of these that came from our nested dictionary. And all you would have to do is, I think for this, this we're just looking at the new columns. So it actually already automatically input the headline columns to the rest of that data frame, to the existing data frame. Did that make sense? Basically, when you have a nested dictionary, that is the kind of process that you want to take. It doesn't have to be this exact process, but this one works. If you can think of one of your own, you can do that as well.
Ish, what if you're trying to overwrite existing column names?
If you want to overwrite existing column names, probably a better practice would be to, to overwrite existing column names. That means you don't want, let's say we don't need this headline column anymore. We can just get rid of this. Yeah, we would literally, I think it's probably safer to have all the data first and then dropping the unnecessary columns. So okay. Yeah, you probably don't want to, I mean, just to be safe, you can exactly overwrite this with like 5 more keys, but yeah, probably the process I would take is I would make all those new columns first and then drop this, just so I can have this as reference.
Gotcha.
Excuse me. Based on the very first line of above, and keys equal to df.headline.ilog, in here. We took the keys from the very first element of the list. And what if the keys are different in different dictionaries?
Yeah, that's actually a really, really good point. This is something that there are ways to check and double check that this is, because let's say there are extra keys in the later dictionaries that are just not in the first dictionary, you actually miss out on all the data. So yeah, there's one way to double check it. You can run a loop through all of these nested dictionaries and just keep like a set of all the keys that have come up and then loop through that. But yeah, that's a really good thing to point out, that yeah, there can very well be inconsistencies, and by doing this, we've basically ignored any of the keys that could have also appeared in other dictionaries.
Yes, thank you.
You're welcome. All right, so last thing about JSON before we move on to APIs is you can also output a dictionary to JSON. So let's say you don't want to work in data frames because it's very common to work in JSON file formats. As we saw with yesterday, it's pretty common for data to exist in dictionary file formats because, you know, you can have a variable number of keys in your nested dictionaries. So another thing that just to be aware of if you end up working with JSON files is that you can output a dictionary into a JSON file format. And very similar syntax to when we were reading the JSON file. So I think reading the JSON file here, we had that F and open. Outputting to JSON, very similar. You're doing the open as well, but instead here we're writing, W for writing, the JSON file, and you would dump your data. So for example, here I'm dumping the data, which is, which I think my data is literally the whole big thing. Yeah, all of this is data. I just want to dump that as my JSON file with F. You can see here, I don't have output on my computer yet, but once I run this, you'll see that there should be an output file. Let me take a look and see what happened. Output.json is here. There we go. Output.json has appeared. So that's how you would write a JSON file, just so you don't know. All right.
And so that didn't retain the data file, correct? The data frame, excuse me. The data frame, it's back into.
That's right. Yeah. For the data frame, you can also save a data frame. You can output a data frame as a CSV, which I think is what we had talked about somewhere in topic 4. But yeah, before I move on, I know that Mark, you were the one that asked about like breaking out like nested dictionaries. Did you need any more like clarification?
No, I think that made sense. Thanks.
Awesome. All right, now let's move on to APIs. So APIs is the term APIs actually consists of many different things. You can use APIs for a bunch of stuff. So like API that stands for application programming interfaces allow things to work with each other. One example that I can think of that's very helpful for explaining APIs is, everybody aware of the app Pokemon Go? I don't mean to have Pokemon references in 2 study groups in a row, but Pokemon Go app, basically you have like a character that walks around in a map that is the map of the real world. And so in a thing like that, you're actually working with a bunch of APIs. APIs is how you can get information from other places without having to store all that information on an app. So imagine if we were to store all the map information in Pokemon Go, you would have to store all the information of all the terrain of the entire world, and that is just not very efficient. So if you've played the game, you know that as you're walking around, different parts of new areas of the map will render as you're walking around, and that's because it's actually pinging some sort of location API to get information about the location that you're around. So basically, API doesn't necessarily have to be for getting data. It can be for rendering different things. It can be for getting information like on the fly. But for our purposes, we most likely will be using API for getting information. Clarification on what an API is. I will admit, when I was working with APIs as a student, I had no idea what it meant. I just knew how to like run the code and get the information. But it did take me a little bit of a while to like read up about it to fully understand what an API was. And I don't even think I fully understand it now. But yeah, an API has several components that we're going to actually talk about as we make our API calls. So first, you have access permissions. All APIs have access permissions. A possible access permission is that anyone can access it, but most APIs, that are run by companies have permissions such that not everybody has access to the data or their services. Also, part of an API, you have a request. We'll actually talk about how we're going to be making requests to API for information. And yeah, that'll be what we'll be talking about. And part of the request, you have different methods. There are different ways you can ask for information, and also parameters, what kind of subsets of information you want. And we'll talk about that in relation to the New York Times API. Finally, contrary to request, you get a response, which is the data or service that you get as a result of the request. So yeah, basically this is what we want to understand. A bunch of this is copied from the lesson, so I won't go through it, but we're going to talk about the New York Times Movie Reviews API. So actually, if we take a look at this, New York Times is awesome because they have a bunch of different APIs. You can take a look at like their archives for all of their articles, books, their NYT bestsellers list. You have information on that. I've actually had a few students do projects on that. And also actually a few students have used this API a bunch and all their different things. They have movie reviews, as I've mentioned, top stories, and most recently they came out with this COVID-19 API that you can use. Documentation is a bit to get through, but really, really cool that that is there. But the one that we're going to work with for this study group is the Movie Reviews API. So let's see, let's get started. To get data from APIs, there is actually a already built into Python library to work with APIs. However, that one isn't as user-friendly as the library requests. So we're actually going to use the request library. It is third-party, but it works better than the built-in one in Python. So we're gonna always import this whenever we wanna do APIs, getting data from APIs, or if we're web scraping, we'll see tomorrow that we also use the request library. So cool. When we're using request, very often we're going to use the .get method. This .get method is basically what is getting us the information. So very cool. Let's take a look at our response. So here, usually when I am faced with a new API, every API works kind of differently, which is, I mean, kind of annoying, but every API is constructed in its own unique way. So it is important to read through some of their documentation. And the good thing is with most APIs, they have like a get started or an example call that you can run. So here on the New York Times Movie Reviews API, if I don't know anything about how this works, I'm just gonna test out the example call and see what happens. So I copied and pasted the example call as a URL. And I'll talk about what this is later. But as URL, I'll do request.get URL as a string and run that. And to take a look at your response, it's all saved under the variable response, and it has the attribute .text just to see what the text is. Cool. All right. So here what we've gotten is that this didn't work. There is an invalid API key, blah, blah, blah. Before doing response.text, let's take a look at the response itself. All right, we got some sort of response code. We got a response 401. Has anybody seen response codes and know of any of these response codes? It's fine, doesn't matter. Basically, response codes help you categorize what your responses are, and they are universal, which is great. Response codes are universal. And so let's just take a look at the Wikipedia for status codes. So let's see, what we had gotten was a 401. And if we scroll down to 401, you can see here, unauthorized. Basically, we didn't have the correct authentication needed to access this API, which makes sense because I think as some of you have worked with the Yelp API, you need to use your API key. So for New York Times, I'm gonna take, for New York Times, you can sign up for an account and get an API key, and this is mine. So what I'm gonna do here is you can see in their example call, they already had this like API key field that I just didn't fill in. So let me just paste my API key there, run that. And now we have a response 200. 200, let's take a look what 200 is. Okay, nothing to worry about now. So now that we have this response 200, let's take a look at the .text. All right, there's some information here, .text. Another thing that works very well is .json. If I do .json, it automatically turns it into a JSON or dictionary file format, and you can actually parse through this the same way you would parse a dictionary. Difference between .json and .text, if you take a look back at .text, this entire thing becomes a single string. So just to be aware, you might not always want to do .text, but just know that this is also available because sometimes .text might be easier to look at. But in this case, I think we can all agree that .json is the clearer format for this.
Hey, Ish, I have a quick question relating to this. So on one of the labs, the request response cycle lab, I was using the rest.status_code and then equal to the request.codes.
Mm-hmm.
And I got a false on that, but I got the 200 code if I tried the response.status_code.
Okay, but it didn't actually get a response. Is that what you're saying?
Well, when I printed the response code, it was 200, which is okay.
Mm-hmm.
Then when I tried to do the equal sign one, I don't know what it's called,
Yeah.
but I got false. So I just, that was strange. And if is there some sort of, indication on which one we should use? And is there a reason that one did not?
Mm-hmm. I would have to actually take a look at that lab specifically to see how they format it. But usually if we're looking at response codes, there's no like right or wrong way to do it. It's just something for you to check that you're actually getting an okay response. So it doesn't really matter which method you're using to check for the code. I will look at I know which one you're talking about, so I'll look at it one more time and I'll let y'all know.
Okay, thank you.
Awesome. Okay, so this next section, I'm going to talk about API keys. And I know that this is a section that I've gotten a few messages about like how that isn't working. So API keys. Should you publicly share your passwords on GitHub? So if you have a project and you're using an API, very likely you're gonna, end up having your API key somewhere here. It's gonna appear in some form on GitHub, and that is not good. Think of an API key as a password. If you end up developing an app that uses an API, you'll be using an API key in your app, and you don't want other people to be able to access that API as well, because they'll sort of get access to the data that your app has access to. Basically, what I'm saying is you don't want to have your API keys anywhere visible on your notebook or on your GitHub. So I'm actually just going to rerun this so it's not on my notebook. Reason being, it's a password and you don't want people to access the data that only you are supposed to have access to. There are actually several ways to do this. I'm going to walk through the way that I do this, and then I'm going to talk about creating that secret folder. So with that, two different ways to do it. Creating a config.py to store your passwords, or creating that secret folder. As I mentioned, I'm going to walk through this way first and then circle back to talk about creating that secret folder on your computer. So for my method, how I actually do this is I actually create a brand new file within the project to store all of my passwords. And how I do that is I actually imagine that this is my project repo. If this is my project repo, I'm actually going to create a new text file. And with text file, you can actually turn it to a Python file, config.py. That's just the standard. A config file is just a standard name for the file that stores your passwords. So in my config.py, I'm actually going to put all my information there. So let's see what I called it. I called it ish key and ish secret. So here, when I sign up on New York Times, they give me a key and they give me a secret here. So I'm just going to save both of those. And I'm actually going to save them as variables. So I'm going to do here, I'm going to just create a variable called ish key and store that as a string. And then next, store ish secret also as a string. And I'm going to copy this over and paste that here. And then save this, and then we're good to go. My key and my secret live here in this non-Jupyter Notebook file, or just not the same Jupyter Notebook that I'm working on. So this is a Python file, which I'll actually talk about in the next phase, more about how you would use and code in Python files. But for now, we're going to use it just to store passwords. So now that I have my config.py, you can actually import the variables from that config file, which is awesome. So what I'm going to do here, my file is called config. You actually don't need to have the .py part, and I'll import the two variables. So if you take a look really quick, this will run, and then you'll see here now if I have my key is stored as a variable here, and my secret is also stored as a variable here. So that's one way to do it. Second part to this is, all right, well, this config.py file is in my repository. Won't it just get pushed up to GitHub as well, right? I mean, that's how GitHub works. It's gonna, any new file you create within the folder, it's gonna send it up there. This is when I'm gonna bring up Git Ignores. So actually, let me just go to a random lab to talk about what a Git Ignore is. Let's see, let's go to our phase 1. We're just gonna go into a random lesson and talk about Git Ignores. So a Git Ignore, as the name suggests, is a list of all the things that your GitHub will ignore. So how many of you have seen like these files pop up? Probably only those of you who have been working locally, but when you're working on a notebook, it actually stores a bunch of checkpoints. You can think of them as like saved, it's like saved data on your notebooks. So if any of your notebooks end up getting corrupted, you can actually use your IPYNB checkpoints to restore them. DS store is also something that's just created by your computer. So all of these, because this exists in the Git Ignore, even though they're in your repo, they won't get pushed up to your GitHub. So basically, whoever created this lab repo on their computer might have had like checkpoints and a DS store, but because it exists in their Git Ignore, is not going to get pushed up to GitHub. So really quickly, how you do that is here on my home page, what you can do is just create a Git Ignore. This specifically is not a GitHub repo. I will walk through this process again on Friday when we talk about our project, but all you would have to do is create a Git Ignore file, tell it to ignore your, that config file. So basically what you would do, you would just create a Git Ignore and then literally just put config.py, and it would know to ignore your config.py and not push that up to GitHub. Questions on that process? So this process of storing your passwords is slightly different from the way that the lessons go through. I personally prefer this because all my passwords, each password is stored within the project repo, whereas for the method on your lessons, you store all your passwords in one folder on your computer. I'm actually going to quickly walk through what that looks like as well. Let me just change my share so that so you can see my entire computer window. All right, so here I have my terminal screen. Let me just clear this. So what the lab walks through is you're going to create a folder that will contain all of your passwords for all of your projects. So let me just CD to get into the base. And what they have you do is they have you make a secret folder. And how you do that, you do make directory.secret. And what it does, it creates a secret folder. If we do an ls, what's interesting is you actually don't see the secret folder that you've created. Any file that begins with a period is hidden. So if we do ls, we don't see it. But if we do ls-a, we actually see that we have quite a few secret files and folders here. So in here, you can see things that I have. We have the bash profile that those of you who might, actually everyone did this, but when you're setting up your Learn environment, you edited your bash profile so that the default is the Learn environment. There's that. You can see here there's a bunch of Git things. You have my IPYNB checkpoints as well, all hidden files. So here now I have my secret file. And what I do here, I can actually cd into my secret file. And so now I am in my secret file. Make this a little bigger. And my secret file is currently empty. There's nothing in there. The next step is to just make a file, make a file with your password. So in the lesson, I remember they actually have you make it in a JSON. So we're just gonna do this, Yelp. I'm actually gonna do New York Times password.json. All right, so if I ls now, that JSON file is there. So this next part depends on your operating system, but all you want to do now is open up that JSON file and save your information in there. So for mine, it's actually going to pop up in a specific way, I know. So the way I do it, I just open the file, open New York Times password.json. When I do that, my text editor, and I'll talk about text editors in the next phase, but this is my text editor of choice. Currently is empty, and I would just store my password that way. So I can say Yelp, oh no, wait, New York Times key equals to, let's actually copy this again. Where is it? Oh, here. Equals this, and then comma, New York Times secret is, let's see, this one. I believe if you don't have like a code editor yet, it typically would open up in like your notepad or your text editor. But because mine, I have it configured as this, I just input this in a JSON or a dictionary file format. So once I have that, saving it, close it out, and I should be able to access that. So if I do a PWD, see where this is, I'm actually going to open up this JSON file. So what I'll do is I'll go back to get like the syntax for opening a JSON file, which is over here. Let's see, where were we? We were over here. All right, another way we can do this is now I can open up, oops, let me copy the PWD again, get the path. Here I have my users, and then slash, what's the file name again? New York Times password.json. Damn, all right. Property name enclosed in double quotes. All right, let me double check this super quick. I think they might need it to be in double quotes. This might be an error that a bunch of you are facing, but let me just double check that this is what's going on. Let me just change this.
Yeah, in the lesson plan, it says the double quotes are important, but doesn't really explain it.
All right, yeah, I think it might be a specific formatting issue and encoding issue. Thanks for reminding me. I didn't, because this is not the way I usually do it, but hopefully now it works. Let's try this. There we go. So now, well, I shouldn't have saved it to data, but now data has my information there. So there's two different ways to do it. It's really up to you how you want to do that. I personally just like to have my passwords stored with each project rather than all in one place, but having it all in one place has its perks as well. So that is storing your passwords. Questions on that? All right, sounds good. Now we're actually going to talk about using the API. So we started with this example call that New York Times provided. You can see here that it seems to be that they're doing some sort of search and you're querying the Godfather. I'm not going to dive too deep into this documentation because every API has different documentation. The way that I found that, unfortunately, the most efficient way to get to know an API is really just experimenting and like trying different things. But everything that you want to get from an API exists from this URL. More specifically, this is a URI, not a URL. So a URI is a uniform resource identifier, and it basically tells the API what kind of information you want. It has your parameters and it has your different methods. So the way the New York Times one is set up is that you have different paths, and the different paths are basically the different methods. So here we're looking at movie reviews. So you can search by, so it seems that you can search by critics and you can search by reviews. So in this case, let's take a look at some other examples. Let's actually take a look at the search parameter. So here you can see that you have different parameters that you can use. You can see that, all right, do you want critics pick? You want to sort it by opening date, like any specific order, any specific publication date, so on and so forth. So when you are doing a search, this is basically how the URI will start. And then depending on what you want, you will string it differently. So for this one and for most APIs, each search query parameter, you can give it as many parameters as you want, given that it's one of the parameters that they tell you you can use, but they are separated by ampersands. So the format here, you start with your different parameters. You tell it parameter equals to whatever value you want, and then separated by ampersands. So this will be my URI for now. And in this example, we're just going to get movie reviews from all the movies that have been released in 2020. So really quickly, URI, this is the base URI for the 2020 movies. And the way that I'm going to incorporate my, my key is I'm actually just going to put the two strings together by doing a plus. So it's just going to automatically add my key to the end of this string. And I'm doing the request.get on that full URI, and then turn that into a JSON format. So let's first do this. Actually, let me just get rid of this and take a look at results. Oops. There we go. So straight away, because I turned this into a JSON, our results are here. So as expected, we got a JSON file format, a huge nested dictionary, and we're just gonna explore that really quickly. So within results, what keys are there? We have our status, copyright, whether there are more or not, and I guess the most important one we're looking at is results. So let's take a look at results within results. So within results, great, we have a list. So these seem to be each of our results. And here, let's take a look at the length of this. Length of this, 20. So awesome, we've gotten 20 results. And just to look at the keys of the first one, we have the title of the movie, the rating, I think MPAs, whether it's like G, PG, R, critics pick, and all this other information on the movie review. So very cool. Let's just turn it into a dictionary real quick. All I did was I took all of these to be the columns, and I just threw it into a data frame. And you can see here, these are the first 20 reviews that we've gotten. I think it's ordered by like when it was published. So yeah, this was published, wow, actually today. And now we have this. For the link and multimedia, if you feel like you need to use it, you can break it out. But for this, I think most of the information that I actually want to see exists in the first layer of the data frame. Any questions about that so far? It's kind of hard to explain the specific API because every API works slightly differently. But for this, the way that I constructed this is because I knew that I wanted to get movie reviews for, let me close this out, movie reviews for 2020. Basically just like skimming this page up and down, you can sort of see, all right, opening date, and you'll look at the date range. If you don't want an end date, you need it to be in this format. And so those are just things that I look out for. And this is the only parameter that I need. Questions about that so far?
So for example, on the URI, you could have added on like the order.
Yeah, for sure. Let's see, for order, let's say I wanted to order it by title. Let's do that. So let's do order by title. I I'm gonna put it in here so I can still put my API key at the end, but I'm gonna do order, and I think it's by title. Let me double check that real quick. Yep. So if it's ordered by title, let's run this, and actually run all of this to take a look and see what this looks like. So now it is ordered by title. Is it ordered by title? Results. Let's see. It still seems to be ordered by publication date. So let me just double check that this is fine. Ordered by title, URI. Yeah, it still gives us a result, but let me see. Yeah, not too sure why this isn't returning by title. Maybe they're thinking about something else, not by the movie title, but yeah, let's try another one real quick. Let's order it by, okay, instead of publication date, let's do it by opening date. By opening date. Oops. By opening date. And I think my issue might have been that I use underscores instead of dashes, but let's take a look and see whether this one worked. All right, so it's already different, which is a good sign. I actually don't need this cell here. And yeah, so now this is ordered by opening date, and it's actually taking it from the start. So yeah, the different parameters you would put in that way. Questions so far? All right, we have 10 minutes, I think should be enough time to finish off the rest of this. One downside to the results that I have right now is I only have 20 movies. And 20 movies, great that I now have this data for 20 movies when I previously didn't, but ideally when you want to do an analysis, you want to have much more information. So for that, there's a method known as pagination, and with pagination, you use offset. So as you can see, offset was actually one of the parameters here, and must be a multiple of 20, and it's an integer. Basically what offset does, and most APIs actually have an offset function, it sets the starting point of the results set, and you can use this to paginate through results. So basically what we have here are the first 20 results, and we're going to use the offset function to get the next 20, the following 20, the following 20, and then put them together to get like a much bigger set of results. So, all right, let me just change this back so it's not ordered by opening date. So you can see more movies. Actually doesn't really matter, but all right, let's see. We don't need this. Let's just run everything just so things are fine. All right, so when we have offset, you can see here, our first movie here was the Blackpink movie. And then if I use offset, and here all I'm doing is I'm adding offset equals to 20 in my URI. And we'll just take a look at and see how those are different. So here I have my second set of results, basically the same process. Did the URI, turn it to JSON, and you can see that the first movie is not the Blackpink movie. So this is a different set of results. And so usually what you would end up doing is you would write either a for loop or a function to get a bunch of reviews, 20 at a time, and then stick them together. Here I have a very, very clunky function. Try not to use this exact function because I don't know what I was thinking when I wrote it, but basically what this works, how this works is we're gonna get 20 reviews at a time and then put them together. Let me break this down. Here I have a list of your results, which I will then at the end turn into a data frame, just because, you know, the way that these results are stored, the main thing is a list within results. So I'm just gonna keep adding to that list. Within this, I had an issue with this particular API that I couldn't do offset 0. Offset 0 didn't work for me, so therefore I had to have separate URIs, one for the 0 case, and then the rest for like 20 and so on and so forth. So you can see here what I'm doing is I'm using a dot format to add 20, 40, 60, depending on how many rows of data I want. So definitely you're going to be writing your own better function to do this, but here, if I run this, I actually have this set up where n times 20 is the number of reviews we want. So if I want 80 reviews, I feed it in the number 4. If I do that, it takes a while. And now you can see that I have 80 reviews. And so let's say for my analysis, I want to do like 1,000. I would put in the number, what's 1,000 divided by 20? 50? Yeah, I would put in the number 50 and just let this run. When you're working with the API, sometimes because you imagine they're doing this for every 20 reviews, it can take some time. So don't get worried if you see that your star icon is, like the star icon here is loading for a while. It's just pinging the API and getting the data part by part. But yeah, this is how you would get information from an API.
So,
Any
and
questions?
the question, is this because they're limiting each poll to 20?
That's right. I think it's actually somewhere in their documentation that they will restrict it to 20. Let me see if it's anywhere here. Maybe it's in here. Let's see, movies. Not sure where, but basically also from making, let's see. Yeah, from making queries, you will also figure out like what that limit is. Most APIs do have a limit. I think Spotify is actually 100. You can get 100 songs data at a time. Yeah, this one just happens to be 20. I don't really remember where it says that, but it says that somewhere.
Okay, thanks.
Yeah. Let's see. Here we go. Nope, that's still the offset part, but yeah, 20 at a time. I think from this you can sort of infer that you'll get 20 results at a time. Yep, so very likely you're going to be doing some sort of pagination for your information. And we'll actually be walking through a very similar process tomorrow when we do web scraping. Cool. Any other questions? Awesome. For those of you, no, actually everybody's working on should be working on the Yelp API lab. I think that's a really good one that you can use to see how like different APIs work. You'll actually see that API works quite differently from how this one works. So just get used to, getting comfortable reading documentation is very important. I try to get that done by Friday, just because I'll be presenting the project on Friday. Let's see, anything else? Does anyone have any questions about, I guess, the Yelp API or anything else?
And the paired work, are we supposed to be doing the Yelp API code along or the actual appendix exercise?
I think it actually might be beneficial to do both. So just for those of you who haven't seen it yet, there is this Yelp API code along over here within topic 9. But also if you scroll down to the appendix, there's a Yelp API lab. Code along has a lot of pre-written code for you. So I think the Yelp API lab, the Yelp API lab does have some like guiding questions that I guess, yeah, exploratory analysis, not really guiding questions, but you'll come up with your own questions just to play around with an API and see how it works. One more note before I let y'all go. For the project, you have the option of using an API. For the project, you actually will be given a bunch of data sets, but on purpose, those data sets are not very clean, also a little bit outdated. So you can definitely work on the project just using that data and like practice your pandas cleaning skills, or if you want to focus on, getting new, more up-to-date data, I will be giving out a list of sources that you can, a bunch of APIs and sources that you can web scrape for the project as well. All right, final questions based on anything I just said. Cool. Well, in that case, I will see you all tomorrow for web scraping and at your one-on-ones. If anyone has any questions at any time, feel free to let me know.
Thank you.
You're welcome. Bye, everybody.